Okay, here is my video, and you'll have to forgive the background noise. My kids are watching Peabody and Sherman. So, this was the chemical equation that needed to be balanced. And as it is right here, this is called an unbalanced chemical equation. So we've got our reactants on this side, and then this means yields, or basically turns into, and this is our product side. So reactants and products, and we have to make sure that we have everything balanced on one side and the other, because in a chemical reaction, there will never be anything that is destroyed or added. So you won't have any extra atoms over here that aren't over here. They have to be on both sides. So the first thing we're going to do to balance it is we're going to write down what we've got, and we're going to write down our C, our H, and our O. You can see there's only carbon, hydrogen, and oxygen over here on this reactant side. And we know that because nothing will ever go away or nothing will ever be added, we know that these same atoms that are over here will also be over here. So C, H, and O. And I like to write them in the exact same order as these ones, because that way it's easier to see if they're balanced or not, because we can see straight across. And these over here, it says COH. So sometimes people will write COH, but I just find that it's a lot easier to write them in the same order on this side than the other side. Sorry, you'll have to forgive my... I've obviously been doing notes because I'm colored up all over the place. Okay. Anyways, so now that we have our CHO and our CHO over here, we need to actually count the atoms that we have of each. So over here, we can see that we've got 3 carbons. So we're going to put the 3 there. We've got 8 hydrogens, and we've got 2 oxygens. So forget about that side, move over here. We've got only 1 carbon. We've got 2 hydrogen. And we've got 2 oxygen here, but we also have 1 oxygen over here. So we need to add the 2 of those together because it's the total amount of oxygen on this side. So we've got 2 plus 1 equals 3. So now, looking at both sides, you can tell definitely that this is an unbalanced equation right off the bat with our carbons. So we'll start there with our carbons. It's always easiest to start not with an oxygen or a hydrogen, so start with something else. So we'll start with our carbons, and just to see where this takes us, we can put a 3 right here, and then we can change this carbon to a 3 here. So I always like to erase my stuff over here and over here because it makes it cleaner, and the more it's scribbled out, like there's been so many chemical equations that I've balanced where I have had to rebalance it so many times that it's just a scribbly mess and I can't make ends of it. Like, it's so confusing. So if you use a pencil and you erase, that's going to be the easiest way. Now, what I was explaining in what I had written out on that one sheet was that when you're balancing these, you need to make sure that you are only applying the subscripts, which are these little numbers down and to the right of each atom. You only apply those subscripts to the atom that it directly comes after. So this 2 only applies to this hydrogen. This 2 only applies to this oxygen. It doesn't also apply to this carbon. This 2 is for the oxygen, this 8 is for the hydrogen, this 3 is for the carbon. So if there's no subscript, you can assume that it's a 1. And that just means there's 1 atom of oxygen, there are 2 atoms of hydrogen. Now the coefficients, on the other hand, they're a big number in front, so it gets applied to everything. You can basically think of algebra, where you have your coefficient and your parentheses, and then you have to distribute the coefficient to everything in the parentheses. So if there's a coefficient here, it gets applied to everything within this molecule. If there's a coefficient here, it gets applied to everything in this molecule. Now, what separates your molecules is like your plus sign or your yield sign. So this 3 doesn't also get applied to the H2. It only gets applied to the CO2 because this is 1 molecule. So we're going to apply this 3 to the C and to the O2, which we've already done it to the C which is right here. Now we're going to apply it to the O2. So the way that we do that is we actually multiply this subscript by the coefficient. And the reason why we do that is because this molecule right here, this oxygen, is basically 2 oxygens. That's what the 2 means. There's 2 oxygens in this. So if we do 3 2 oxygens, if we have 3 2 oxygens, then we'll have 6 oxygens total. Hopefully that made sense. That's where it gets really tricky. But you've got 3 2 oxygens, so you've got 6 total. And then we also need to count into effect this little Lone Ranger over here. So we've got 6 plus the 1. So we've got a total of 7 oxygens. So now if we look back over here, I'll erase this stuff because it might not apply in a minute. We'll probably have to change it. If we look over here, we've got our 3 carbons and our 3 carbons, so we're totally balanced there. But then we move down here and we've got 8 hydrogens and only 2 hydrogens. So how would we bring this one up? How would we change this 2 to equal an 8? Well, we can see here that the hydrogen has a 2 subscript. So what times 2, is going to equal 8? Well, we know 4 times 2, 4 2s of hydrogen. Here's our hydrogens. 4 2s is going to equal 8. So a 4 in front of the hydrogen equals 8 hydrogen. 4 times 2 equals 8. But we also have to take into effect that this coefficient, again, because of algebra, gets applied to the entire molecule. So we've got our 4 H2s, which is 8, but we also have 4 oxygens going on over here. So these 4 oxygens we have to also apply to these 6 oxygens that we have. So the 6 plus the 4 is going to equal 10. So now we've got 3 carbons, they totally match. We've got 8 hydrogens, they totally match. And then we've got 2 oxygen over here and 10 oxygen over here. So we can't take this down at all because it has to be where it is in order for the hydrogens to balance. So we need to come over here and figure out, okay, how do we make this 2 oxygen into 10 oxygen? How do we balance that out? And for here, it's kind of easy because we only have 1, and that's going to make it 5 times 2. Remember our parentheses, so 5 times 2 oxygens, 5 times 2 is 10, so we can change this little guy to a 10. So we should have 3 carbons, they balance out, 8 hydrogens balance out, and 10 oxygens balance out. So if you were to rewrite, sorry, I'm gonna knock you around here. If you were going to rewrite your formula, which a lot of times they have you rewrite it, your formula would then look like this. So this would be your new formula. Your balanced chemical equation would look like this. So you've got your 3 carbons, your 8 hydrogens, your 5 O2s, and then over here you've got 3 carbons, basically 6 oxygens, and then your 4 H2s and your 4 O's. So hopefully that made some sense in how it's balanced, and if not, I can totally make a video for the second one too. Although this was a long video, sorry, you're probably like, okay, already, I get it, let's do this thing. But if that doesn't make sense, let me know and I can totally make another one. And I think the more you do it, the more you're gonna get it. It's really, truly just about practicing and remembering those little things. The subscripts only apply to the one, the coefficient applies to the whole molecule, and then make sure you don't miss those Lone Rangers, because oftentimes in the product, you've got like O's over here and O's over here, or H's over here and H's over here, and you have to make sure that you're keeping track of both of them. In fact, sometimes when I do my oxygens, or when I do whatever that has 2, sometimes I split it up like this so that I can keep better track. So I'll say, okay, over here, this specific oxygen has 6. And this one has 1. So I can keep track of it better. So when I change this one up, okay, now that one has 4. So I can see 6 plus 4 equals 10. So that's one way you can keep track of it too, is by making sure that you note, okay, there are 2 here. So when I'm doing this number here, I need to remember, okay, I need to apply both of those to the overall figure there. So anyways, let me know if you need another video. I would be happy to make one. Good luck.